Electricity powers our modern world. Most of that power doesn't flow in one direction like a battery in direct current. It alternates, back and forth, in a sine wave. This is the foundation of alternating current. In AC, the flow of electrons changes directions many times each second. In Australia, this happens 50 times each second, resulting in a frequency of 50 Hz. As the current flows forward and backwards, its voltage smoothly rises and falls, forming a sine wave. This represents how voltage and current change over time in AC systems. The sine wave comes naturally from how electricity is generated. Inside an AC generator, a coil of wire rotates in a magnetic field. As it spins, the amount of magnetic field cutting through the coil changes continuously. According to Faraday's law, this changing flux induces a voltage that follows a sine pattern. At 0 degrees, the voltage equals 0. At 90 degrees, the voltage reaches its positive peak. At 180 degrees, it returns to 0 and reverses direction, forming the negative half of the sine wave. The key characteristics of a sine wave are amplitude, frequency, period, and phase. The amplitude or peak voltage is the highest voltage. The frequency is how many cycles occur per second, while the period is the time for one cycle. Phase describes timing differences between waves. One wave can lead or lag another, especially in inductive and capacitive circuits. AC voltage isn't constant, so we need a way to compare it to DC. That's where the RMS value comes in. It represents the effective DC equivalent, the amount of steady voltage that would produce the same heating or power effect. For a pure sine wave, the RMS voltage is equal to approximately 0.707 times the maximum voltage. For example, when a wall socket says 230 volts AC, that's the RMS value. The actual voltage is swinging between plus 325 V and minus 325 V, but on average, it delivers the same power as 230 VDC. The sine wave is the heartbeat of AC power systems. It is smooth and predictable, making it ideal for power generation, transmission, and electronics. Application ranges from your home power socket to audio signals and radio waves. In conclusion, the AC sine wave is the invisible rhythm that keeps modern technology alive.